Good evening, everybody, and welcome to our 10th now installment of Members Presents. We've had an awesome program so far, so yeah, this is the first
I had more clapping to them.
Okay, sounds good. We've become more official as we've gone on, and we even have a videographer, which is one of our members, James Woods, who's behind the camera.
Thank you, James.
Thank you, James. And he's also posting these on YouTube, on our YouTube channel that we have. So that all got developed this year coming out of doing this whole thing, which is super cool. And we even have a couple of our past presenters in the audience tonight, which is also cool. Before I introduce our speaker, who's got the first slide up there, next month on December 4th, which is the first Tuesday of the month, we're going to have Ron Evans, Keenan Evans, and Christine Westermans, who's presenting them tonight, but she's also going to help out next week, do a 20-minute start-to-finish demo of a rammed earth wall, and indoors. So they're going to set up to do construction indoors, little mini demonstration of that, so it's going to be a pretty awesome presentation. Also, another announcement, everybody probably was made, or except for the newcomers, maybe they didn't hear, but we're going to be having our second annual ECI holiday potluck. And last year it was at SWCA, which you all remember, but this year it's going to be at SSA, which is the Southwest School of Art campus, which is where we're at right now. It's going to be in a different room because we're expecting it to be a bigger crowd. So the room is TBD, but it's going to be on December 9th from approximately 2 to 4 p.m. here at the Southwest School of Art. So please join us for that. Okay. And
it's across the street from here.
It should be, yeah, we're thinking it's going to be in the lecture hall that's just across the street, but it'll come out on the invitation in the mailers and online and all that. And tonight we're excited. I think this is super cool. I don't know technically how much it'll tie in, but just continuing on this discussion that got started at the Bruce King lecture that was last month. Christine Westerman, she is a senior project manager at SWCA Environmental Consultants, and she's also our treasurer and board member of the ECI, and she's going to be speaking to us tonight about biomimicry, learning from nature in building and landscape. She brought along a book, which I think she'll hold up maybe during her presentation, but I think it's just kind of a nice continuum of that discussion there. So again, without further ado, Christine Westerman, everybody.
Thanks. So as you all may know, I am a biologist, not an architect or builder, except when I help Ron, by handing him tools and things. So I'm going to give you kind of more of a biological and ecological perspective, but tying into earthen construction. So we'll start with definitions, and the idea, or what got me the idea to do this talk, was this little article in National Geographic on a building in Harare, which we're going to talk about in a few minutes. So I brought that with me. And the definition that this article had was the imitation of natural biological designs or processes in engineering and invention. And then also the Biomimicry Institute had a definition that's more tied to biomimicry as a way of looking for sustainable solutions by emulating nature's ideas. So biomimicry isn't new. I mean, nature has been doing biomimicry forever. We have butterflies that are being a leaf. That's a butterfly wing. We have insects that look like sticks. We have a caterpillar that looks like bird poop. So nature has been playing these games for a long time, and human beings, we assume, we don't know what was going through the minds of our earliest ancestors, but we know they had to be keen observers of nature in order to survive, in order to be successful hunters and gatherers. And I think we could imagine that our ancestors looked at vines and thought, that they might have gotten an idea for making rope or twine or thread that way. And they looked at, you know, the birds who were building thousands of years before we were. They might have looked at a bird nest and gotten the idea to weave, to do fabric or thatch. And these cliff swallows that actually build nests out of fibers and mud. And we might have looked at that and got the idea for making pots, maybe even making buildings like they do. Just throwing out some of the interesting biomimicry concepts and ideas that are more recent is one of the most famous stories is the guy who invented Velcro looked at burrs like these cockleburrs and said, you know, I can come up with a fastening system that looks like this. We've been looking at how plants take the energy from the sun and water and CO2 and create sugar and create the structure of the plants. They basically take those three basic things and build a plant, you know, maybe a redwood tree 20 feet in diameter out of air and sunlight and water. One that you hear a lot when you do research on biomimicry ideas is iridescent colors, because insects and also bird feathers create these iridescent colors through the actual like cellular structure of their exoskeletons or the wings or the bird feathers, and it's all natural materials. It's basically chitin that they can do these iridescent effects, and companies like 3M, for example, are looking at how this is done in order to come up with window films, for example, like something to shade windows or affect the amount of sunlight coming in. Spider silk is another big one. We've been looking at spider silk for a long time and trying to figure out how can we duplicate that kind of strength in a natural material. It's 5 times as strong as steel of the same size. It's more elastic than rubber bands, and obviously it's biodegradable. You know, it's basically from nature's point of view, it's an inert substance. And oh, go ahead back, just because I'm gonna just let you know for fun that that's a picture of one of the endangered cave spiders that occurs in Bexar County. That's on the endangered species list.
Where is that at?
That was taken in, I think, Madlode Cave. It's in one of the cave preserves. Our company does research on the cave spiders, so I make the cave connection pretty easily. So another example of biomimicry is the concept of evaporative cooling, or using evapotranspiration to cool, like in a green roof. As you all probably know, evapotranspiration is the process of the plant drawing the water up and drawing the water vapor through the plant and exuding it through stomata in the leaves, which causes evaporative cooling. Oh, and my dog, pants. And I thought that wattle and dog construction is a good example of biomimicry, because it's pretty much the same thing that cliff swallow was doing. If you watch a cliff swallow building its nest, it goes and collects a piece of grass, and it goes over to a puddle, and it dips the grass in the puddle, in like a muddy puddle, to coat it with mud, and then it flies up and it puts it on, and it builds its nest out of one strip by strip at a time of muddy pieces of grass. So that's an example actually that's using bamboo for the thatch part. And Biomason, one of the reasons I brought Bruce King's book is this is an example that he talked about in his lecture and has in the book, where Biomason company has come up with a way to create bricks and pavers that use no cement, no Portland cement, and no baking by using a naturally occurring enzyme that they produce through bacteria, which is actually pretty similar to what termites do. Termites, eat grass, eat vegetative material, but it's actually bacteria in their guts that are digesting the material. So speaking of termites, this is where the whole idea got started with this building. It's called the East Cape Building in Harare, and the people who design it specifically say they got the inspiration by looking at termite mounds and how termites build their mounds. So if you look at a cross-section of a termite mound, the termites actually live in the underground part where it's cooler, and the mound itself is primarily created for ventilation. It acts as a chimney for the hot air to rise and for cooler air to come in. When the temperatures are lower, the cooler air will go down, and at night when the hot air will go up. And another thing that's interesting about termites is they actually have kind of underground farms where they grow fungi for their food. So some of the benefits of this building, some of the ways that they were copying the termites' ideas is it has thick walls for thermal mass. It's actually a concrete building, not earthen, not natural earthen, but it's pretty tall. So I don't know if earthen was an option they considered or not. And the other idea they got from the termites is that it has kind of a central courtyard going through it with chimneys all the way along the building, and that's basically a central area to act as a chimney for warm air to rise through the building. It has double layer floors so they can use low power fans to ventilate the floors to keep them cool. It has a bumpy exterior, and that's actually intended to increase the dissipation of heat off the building as breezes blow by, kind of like a cactus. That's another biomimicry thing, a cactus, or if you go to the desert and everything has thorns, it's not just to keep animals from eating them, it also helps dissipate heat from the plants. And it uses an average of 35% less energy than similar buildings in the same city that were studied. So, sort of going on to the extreme end of looking at thermal mass, and because our company works with caves, I thought about caves. And the cave environment here in Bexar County is, average temperature in a cave is 68 to 72 degrees all year round. If you go deep enough, if you're up by the surface, the temperature is going to fluctuate. But as you go down into the cave, you get into where it's a stable environment. The temperature is pretty much the same all year round, or a few degrees variation. The humidity is stable all year round. That's the environment those cave bugs happen to need. So that's the kind of environments we study. And it's interesting that if you look at what the average temperature year round in San Antonio, it's 69 degrees. So a cave, when you get into the stable part of it, has the same temperature as the average temperature, of the area. Now, I'm sure you all are pretty familiar with the concept of thermal mass, and these definitions came from this website called earthenci.org. So thermal mass is the capacity of a material to absorb, store, and release heat energy. And its ability to do that is based on its density, the rate of thermal conductivity, obviously the actual thickness or mass of the wall would affect its ability to, how much thermal input it can absorb. And the thermal flywheel effect is that cyclical pattern of where the mass wall can absorb heat during the day and then dissipate or release the heat at night when temperatures go down. So you picture the wall, the sun's beating on it, the heat's going to penetrate through the wall. And then depending on the material and the size and how hot this input is, it's going to affect, and the density and things like that. That heat could go all the way through the wall, or maybe not all the way through the wall, before it cools down enough for it to start releasing back the other direction. So I happened to find this example from California where they were looking at concrete walls, and they said that the time delay for 8 to 12 inch thick concrete walls on the order of 6 to 12 hours, as far as how many hours for the heat to go into the wall and then start releasing back out. I know one of the things ECI is interested in doing is getting more data from earthen structures, mass walls here in our area, in our climate, and with known mixed designs to see what our actual materials are doing as far as the thermal flywheel effect. And obviously variables that can affect that are the wall material thickness, the temperature ranges, the diurnal variability, and whether or not that wall is shaded. So I just showed some examples of human-made caves. This is like our idea of trying to mimic the cave environment by building these rammed earth and compressed earth block and adobe residences. So another interesting example is Mesa Verde, which is in California. And this is a natural rock overhang and cave, but the Anasazi, who we don't have, writing examples from them or know how they came up with this, but presumably through trial and error, they maybe originally lived in the caves and then eventually started building and started figuring out that where they build their structures affects how warm and how cool the walls are. But the way a lot of their dwellings are set up is that they're south facing, so in the winter when the sun is low, it's shining in there and it's heating up their walls during the day, and at night those walls are dissipating those heat and helping to keep the dwellings warm. During the summer, when the sun's higher, it has this overhang that shades the buildings and keeps them from getting too hot during the summer. So that's a pretty sweet deal they had as far as where they got their dwellings set up. Do we have any questions so far? So just since I'm coming from an ecological perspective, and I said I would say something about landscape, I just have a couple slides left, but one of the recent efforts that a lot of regulatory agencies are looking at, and landscape architects and engineers, is called low impact design or low impact development, which is trying to use natural processes or copy natural processes to help moderate flooding, manage stormwater, improve water quality, and protect streams and wetlands. So this is an example. This is actually a San Antonio example. It's a library. This is the parking lot area, and these are rain gardens that have been constructed to capture some of the runoff from the parking lot, and then that runoff is filtered through the rain gardens, and they're planted with a variety of plant species that have the ability to kind of adapt to that fluctuating soil moisture, which is going to go up and down depending on rain events, and capture that moisture, evaporate it, keep some of it from going into the street or into our storm drains, and also improve the water quality. So I just like to put out a pitch for if you're building your beautiful, cool rammed earth house, don't just think about having a yard that looks like a golf course. Think about having a yard that resembles natural grasslands. If you look at what is in a natural grassland, there's not just one or two species, there's like dozens or hundreds of species, different grasses, forbs, wildflowers. That kind of area can support a whole lot of wildlife. The golf course, pretty much hardly anything is going to survive there, animal-wise, you know. So that's just going to be a lot better for your urban wildlife, or if you're out in the country, your native wildlife out there.
So I have a question in relation to that, because I think we're not that evolved in when like we do a new construction, kind of mow over the entire site, and then maybe we displace the topsoil, maybe we put it back, but it doesn't behave the same.
Mm-hmm.
And what we're used to doing, like designers and also like occupants of the buildings, is like in suburban development, for instance, is well, now you plant grass, and now you every year you have to maintain the grass, which is labor and time and money and energy intensive, but also that includes like putting on pesticides to keep the bugs out, which you kind of need to do, and you get annoyed when your neighbors don't do, because then you know what I mean, like kind of thing. Everybody has to be on kind of the same page with that. So what do you do? How do you maintain something like this and also live with it comfortably? Like, I don't know, like, are the bugs different once you, or I'm just wondering, like, what do people do? I know if it's in the country, you just get used to it, right? It's different. But how could you bring that into a more
I'm thinking
suburban?
of like Polonia's yard. We have a friend who lives, a couple miles from I-10 in a suburban neighborhood. She's pretty much taken out her whole yard and replaced it with, as far as grass, there's a little bit of grass, but almost everything has been replaced with, it's more like this, or perennial flowering plants.
Xeriscaping?
Yeah, it's xeriscaping, it's a lot of native plants. I don't think it creates more issues with insects. You get more butterflies, you might get more bees, but I don't think you're going to get more obnoxious insects.
Yeah, I do a lot of native plants, and you create an ecosystem, so you really don't, if you get for instance, the dragonflies and damselflies will eat the mosquitoes, and if you see a lot of those around, you're less likely to see mosquitoes. The problem is that when they spray too much for the mosquitoes, and spray the wrong stuff, then the damselflies and the dragonflies get a big dose of that, and they end up not being around, then you get more mosquitoes. Or, like right now I have the dripping sweet, what's that stuff called? Honeydew, I think, that comes down, and then I've got tons and tons of flies, but they're pollinators. We need pollinators. They're irritating for a few weeks, and my car looks like horrible, but it'll be done. And we need pollinators in order to have our food. I think we don't realize the amount of, so we try to create these little cement jungles or places that are sterile, sort of, but that isn't gonna be sustainable.
Yeah, and you'll also, if you're not spraying, you'll have spiders, and spiders will catch the flies and other things. And
exactly.
Like Kamala was saying, it's more like then you'll have a system that works where nothing gets too out of balance, or you have a bunch of one thing.
And you can sort of, there's people, that's one of the ways that people do control insects naturally, is through different, if you're noticing, what is it, the nematodes, you put those down for fleas and stuff like that.
There might be a natural approach you can take. Yeah, wasps will eat caterpillars if you kill caterpillars. And?
Well, something that I wanted to say was companionship planting, and there's the whole idea of permaculture. Lots of ideas come into play, and something I get irritated with. I always hear green, and like, oh, you just put grass in. The same thing that you're saying, and it's just like, okay, just because it's green doesn't make it green. The idea of design is eliminated when you say green, because it's just green space. No, you have to design it, and
so you need to be conscious about it.
Right, exactly. And you can't design nature. You can't design an ecosystem in the same facets as you do architecture.
Mhm.
Because architecture and construction is okay. We have a time frame of about a year, 2 years, and then you do it. That's not how it works.
Yeah.
Which can do a lot with species selection. There's a lot of freedom in design if people pay attention to more attention to species selection, and and it's okay to mix even native plants are always preferable. But correct me if I'm wrong, you can mix non-natives provided they're well suited to the environment and they're not invasive. That's a big caveat that people are constantly skipping. But Chris's her experiences in revegetating, sort of restoring grasslands on huge swaths of land, so she's used to dealing with this on a much grander scale. I think the question Ryan was asking is, in an architectural setting, people expect a certain look.
Yeah, and that's interesting because if you're growing native plants, or what I find in my yard, which so I'll define my yard as the small area around my house and not the whole 7 acres, but things do move around, they reseed, they'll pop up. Some things don't work where you put them and other things come in. And if you have some tolerance to sort of letting it go its own way a little bit too. But also I think having tolerance to insects, like it's okay to have a spider in your yard and a caterpillar, it's not going to hurt you. And if you start to learn to look at them close and appreciate them.
Is there a minimum size of a plot of ground so that it doesn't get overwhelmed by the outside world? I mean, get washed away in the noise?
Well, a lot of it's going to depend on your site, but I think there's a lot you could do even if you just had a very small yard.
Cracks in the cement.
Yeah. And any place where where you're doing more pervious cover, just that is going to help a lot. And where you're increasing your biological diversity, that's going to help even if it's just one little spot of it,
Life will find a way.
Yeah.
So I do see that like something will always find a way to grow on like hard dirt, but things you want don't actually seem to grow on hard dirt. And hard dirt is because you did a construction project and now it's
Yeah,
it
because we
wasn't
don't
hard.
take care of the soil.
Yeah.
Mhm.
So like what are basics for, because like nobody ever taught me anything about the soil in architecture school, and so it's only like through things I've learned through work or through, and not even that much because I haven't made a study of it yet. But what are some like basics that you could what are some basic precepts or concepts for like having health of soil in an urban environment?
Because like one of the things is if you were to take a beautiful fluffy, loam and run over it with a tractor, you can't unfluff it. It's like if you ran over a brownie with that tractor. You can't fluff the brownie back up, right?
Right.
It's if anything you can do to just protect it from compaction would be the first thing. If you do have an area that's compacted, pretty much what they'll recommend is that you would like scarify this surface. So one thing maybe you could do is remove the topsoil and stockpile it, and then let the equipment do that. And then you scarify the surface like you rake it, or with deep, like a harrow or something, to scarify that surface and kind of, wouldn't necessarily fluff it, but loosen it back up and then put the topsoil back.
There was a time when I saw an article, and it had to do with tracing interconnectivity of southwestern tribal communities. And the paths that they had created over a period of decades, centuries, were not visible on the ground.
Mm-hmm.
But when they took aerial photographs for heat signatures,
Yes.
it came out that what had been trampled even decades or even centuries ago still had the compaction that would absorb or reflect heat differently, so that the paths became very clear. And so they decided or concluded that the communities there was a much more complex society and interactive society that had occupied this area that people ever could have realized without those sensing.
Huge network
It
of
was
like
fascinating.
trading
It was like outnet
and
trails.
traveling back and forth. Yeah, it was amazing.
Yeah. Or college campus where there's trails where they weren't planned. And
Yeah.
and
But where
trails
people
nobody
go.
walks. Yeah, like
Exactly.
that.
There's also a lot of new work out on soils in terms of the health of the soil and the extent to which it's alive. So if you're feeding stuff in that will create more organic matter in the soil, then you're creating more mycorrhizal fungi and you're building new soil. And
Yeah.
that's the best way to, compost coffee grounds.
You want to go to the next slide? Because, yeah,
Maybe you're
that's,
gonna,
a soil, true soil is a system. It's not just dirt sitting there. It's a whole system of pore space and fungi and micro organisms and roots and the oxygen and CO2 transport and water transport back and forth. But just one thing I'd like to say, like bison's like one of my favorite animals, and before European settlers came here, we didn't have cows, we had bison, and they grazed the grasslands, which was real grasslands that we showed before. And the bison came in and they cut the grass and they pooped and they left. And the grasses used that poop as fertilizer and grew back. That's what those grasses are evolved to deal with, being cut once in a while, but having time to recover, and even being burned once in a while and having time to recover, and having natural fertilizer put in. And what we do is we cut the grass and we take away the clippings, and then we have to go buy something and put it on there. It's like, oh, that's silly, The system is there and the system works if you just do it the way it's supposed to work.
I read an interesting article once about people wondered where the grasslands came from, why they were such extensive right now. To your point, some folks in the Park Service, they decided, because of the buffalo heritage, what would happen if you put up a fence around an area that kept the buffalo out of an area of grassland? And they did that for 2 or 3 seasons, and they found that trees started to grow out where the buffaloes were. Because they weren't doing just as you said, they weren't eating away the grass, eating up all the little shrubs, and nature would return to a completely different ecosystem if you kept the buffalo along.
Yeah.
So they were part of a huge.
Yeah, and you've probably heard that a lot of Texas used to have a lot more grassland than it does now, because when you brought in the cows and put up the fences, it really changed the system. I just wanted to, give you all some of the resources that I used to put this together, and I just have one more slide that says questions, but it has my second favorite animal, which is the dung beetle. And it's you don't see those down